Now, continuation of our previous lecture. Today, we are starting the concept of the quasi concave and quasi convex. So, before starting the concept of the quasi concave and quasi convex, we should know about some important concept related to this topic. What are level sets, upper contour, and the lower contour? And this is kind of the three-dimensional space, and in that three-dimensional space we have multiple values of functions and domains here, and how we can distinguish what is upper and lower contour, or what is the level sets. And first of all, everybody knows about the concept of indifference curve. It is very basic concept. And indifference curve, let's say if we have, for example, this is kind of IC. Okay, we all are the familiar with this concept, and we assume that let's say this is X and Y, and this IC uh, have different values subject to utilization of X and Y. For example, if we mark any point here is A, it means that A has some sort of values from X and some from Y. It is understood. And if I say that, for example, this is point B and this is point C. So for B, I can write B is at most, clear? At most means at most equal to A. Can I write this one? B is at most equal to A. What does it mean? Either it is less than A or equal to A. Okay. And similarly, one important thing is that if we mark C, so for C we can say that C is at least equal to A. That is equal to A and greater than A. So it means it is at most, and this one is at least. At most and at least. Okay. Now, for example, let's say if we select any value along this IC curve, and we say that functional value of B, clear, or at B is at most equal to the functional value at A. I can say this one now. And similarly, I can say that the functional value of C is at least equal to functional value of A. When we compare these values, so we need to define some level of set. That level of set is called levels set. That is actually the benchmark. On the basis of this benchmark, you compare some numbers or some binary relations or some values. So in mathematical term, this is called level sets, or uh, in case of uh, economics, we call it indifference curve. Clear? Up, what are the kind of the level sets? For example, there is some technical definition of level set. What is this? Then we will decide which one is the level set or which one is not the level set. First of all, a function f consists all the points, all the points, all the points in the domain of function f, of function f, at which at which at which the function has certain value, it is called level sets. Level sets are IC, IQ, isocont, production possibility, PPF, production possibility frontier, ISO profit line, etc. Or the budget line, or budget line. Okay. Yeah. What I am saying, these are the level sets, because these set value you decide to compare the other values. In case of indifference curve, you decide which value of indifference curve is going to be tangent with your budget line. Clear? So you decide that level. Okay, now it is the level, value of level of the functions, and this is the benchmark which I have to achieve. Clear? Because you know that it is indifference map, multiple indifference curve you have. Clear? So multiple level sets you have. Okay, this is one level set, this is another level set, it is another one level set, and that you select any one. Clear? एक select करते हो, then you decide to optimize on the basis of this level set. Clear? And similarly, what is another definition or the another value of the function you need to fix? Which one is isocon in case of the production function? In case of the exchange economy or the trade, the production possibility frontier you will have clear. And similarly, ISO profit line, which decide to your benchmark of the profit, and the budget line in case of the consumer. Clear? Up now, on the basis of the level set, you decide which value will be higher as compared to this value, or which value will be lower as compared to this value. For example, let's say if we have this IC curve, okay, this IC curve, right, and we select or mark any value A along this IC curve. This is our level, यानी benchmark in basic आम term में, that is our benchmark to compare. Clear? Or now that benchmark, clear. अब now I am comparing this value. अब now all the possible values are here of indifference curve. Clear? अब these all possible values are called आपके पास lower contour sets. These all values are called lower contour. Clear? And now it is very simple, but it is not generally simple because, for example, okay, अब now this is kind of the cone or kind of the n dimensional or the multi-dimensional function. This may be like this one. Okay, this may be like this one. For example, if when we move upper side, so the functional value is going to be increased. It is understood. When we move in this side, the functional value is going to be decrease. Clear? कि अगर मैं इस तरफ नीचे आता हूँ, the functional value is going to be increase. That is the reverse image of this cone. Clear? अच्छा. अब, for example, when we cut from the top of this one, clear, half, or this value from, clear, यहाँ से कट करता हूँ, तो all the parts lie in this set. If, for example, this is the set, अगर मैं इसको कट करता हूँ तो all the points lie in this set. Clear? Similarly, अब यहाँ पे अगर मैं करता हूँ let's say इसमें अगर I am taking some linear combination inside this one, it is completely the convex set. Clear? अगर मैं इसके linear combination लेता हूँ as compared to this value, so all the linear combination all lie in this set. Clear? Compared to A. So if the all the linear combination or the lower contour sets are convex, मैं ये कह सकता हूँ all the lower contour set are convex. Clear? If all the lower contour sets are convex, lower contour, clear? These are the lower contour. So the function is quasi convex. All the upper contour set are convex. The function is quasi concave. क्लियर करूंगा अभी, ठीक है? अब ये नोट कर लो, अभी नोट कर लो, पहले बता रहा हूं.
लोअर कंटोर में कॉन्वेक्स होंगे.
Exactly. अब now exactly. अब आप ये देखो, these are the lowest value. If I cut off this value, clear? So remaining will be the part of the function. Clear? Okay. So that is, it is the lower contour. Clear? So that you will have the convex, quasi convex. Clear? And what about this one? When we cut off, the remaining are the part of this one. सही है, chop off this above value of the function, so upper contour. सही है, तो all the remaining are the part of this one, so it is called the quasi concave, not the concave, quasi concave. Half to quasi concave. अब now what I am saying कि look at this one. These are the three-dimensional space. Clear? So in that three-dimensional space, these are different level sets. Clear? And these level sets may be isochron, maybe IC curve, maybe PPF, or if these are linear, for example, sake of understanding, so these are the budget line as well. Clear? In case of the three-dimensional space. So in case of the three-dimensional space, when you are going to optimize, so simultaneously you will have the different level sets. Isocont, IC curve. For example, in case of the consumer theory, you will have the IC curve as well as you will have the budget line. Both are the level sets. And you take the tangency at the time of optimization. Clear? So you will have the multiple level sets there. Right? Because or when we generalize, so it means that it will be the n dimensional space. Right? So normally for the sake of understanding, हम इसको ही assume करते हैं. अब मैं ये कह सकता हूँ कि all the lower contour sets are convex. Clear? All the lower contour sets are convex. It is called quasi concave और upper contour कहला रहा है. ठीक है, lower contour कहला रहा है. और ये क्या हो रहा है? Upper contour. तो what should be upper contour? Upper contour, it means the functional value of f it as least greater than a. Clear? That is called upper contour. The functional value of f it at most equal to a. That is called lower contour. Clear? But first of all, you have to decide the benchmark. That benchmark is called the level curve. To decide the upper contour or lower contour. Clear, bilkul? Okay. So now the definition is
Quasi.
upper contour, that is the level sets, a function f consists of consists of all the points in the domain at which f has at least at least a certain value. It is called upper contour, function f consists of all values, all the points, all the points at which f has at most all the points in the domain, all the points in the domain at which function has at most at which function has at most uh, certain value with respect to a. It is called lower control. Okay, so now it means that first of all, to define the cosine concavity, you need to clear about the upper contour or the lower contour sets. Then you can decide which one is level convex, quasi concave or quasi convex. Clear? So I think we should stop here, or In the coming class, we will discuss in detail the cosine-concave because there are some technical discussion related to the cosine-concavity or the cosine-convexity. So we will discuss in detail in coming class. Clear? Thank you. So thank you so much. Allah Hafiz.